Brian Castillo, please come to the front office before you get on the bus. Please come to the front office.
Okay, this example, I'm doing a video, so you can just ignore me. This example is about a projectile that's launched horizontally off of a cliff. The cliff is 40 meters high. The ball is launched horizontally, so we could say that's the same thing as at a 0-degree angle. And let's say it goes off 12 meters per second at a 0-degree angle. So you're given 12 meters per second horizontal, and you're given the cliff height. And you've got to fill in the rest of this information. Okay, so since this horizontal is the same thing as 0, I could use the cosine and sine to get the x and y components. And my x component, 12 cosine 0 would be 12, and 12 sine 0 would be 0. So it has no vertical velocity to begin with. So its velocity vector would look like this. And as a matter of fact, I went ahead and drew some velocity vectors. As the ball goes down, the horizontal velocity always stays the same because there is no horizontal acceleration. Vertically, it speeds up as it goes down. So I've got the vertical acceleration listed here. Notice the velocity vectors vertically go from 0 to larger and larger. Okay? Give me just like 2 minutes. But you can come in and sit down. Okay, so I've got my Vx naught and my Vy naught. Vx is equal to Vx naught. There's no change in horizontal velocity. Horizontal acceleration is 0. Vertical acceleration is -10. X naught and Y naught are 0, so we've covered these bases. Remember where it very first begins is the origin of the problem, so 0 is up here. The ground down here would be a -40 because the ball fell down 40 meters. Okay, so we need to calculate these three things, and the easiest thing to do is to calculate Vy first without knowing time. So I use this equation to calculate Vy. Vy naught is 0, so it's gone. So Vy is equal to the square root of 2ay. Remember there's a plus minus on here. So I get 28.3, and because Vy is pointing down, Vy is negative. Okay, to get time, I can use this equation. Vy naught is 0. Looking for time, so rearrange this for time, and I get 2.83 seconds. Or if I think about it, if it gains 10 meters per second every second, it would take it 2.83 seconds to gain 28.3 meters per second. And once I know time, I can get x using this equation where x naught is 0, take my Vx naught times my time, and this gives me my x, or I just rounded it to 34.0 here. So there's a basic example for a projectile launched horizontally.